Hello, welcome to ZIM Capture. I'm inventor Dan Zen. And ZIM at zimjs.com is an open source framework to make interactive media on the HTML canvas using JavaScript and Create.js. In this capture, we're going to be taking a look at 3D in ZIM. It will be using ThreeJS and a helper class made for ZIM. Let's take a look at the site now at an example of 3D in ZIM. We'll scroll down. And this is one of the ZIM bits, one of the later ZIM bits made right here, 3D with ThreeJS. So we'll open up that, and we've got some native cubes there. And what we're doing is we're using a ZIM interface to control those cubes. So rather than the ThreeJS traditional orbit interface and stuff like that, now if you're making something on the stage you want to spin around and that's it and nothing else, then probably just stick with ThreeJS. Although you may like how we've applied our controls to that as well, so we're going to show you that with the new swiper class. And then this one right here controls the spin of it, wee, and the direction. So how fast, and the direction from a dial. Okay, so that's ZIM with ThreeJS. We're going to show you how we can bring in a model. So let's do that now. Oh, you can view the code for that, and when you do, up at the top of the code right here, cladunk, is our ThreeJS call and our helper class. So this is where you can find that information. And then if you want to find out more about the helper class, you can just copy that URL. It's not quite in the docs. It's in the file itself. So if we go here, there's all sorts of information about the helper class, including how we can create the helper object from that, the parameters, various methods like positioning and scaling and these types of things. Okay. And then, of course, the helper class is all in there. Now, the helper class, if we take a look at it, it's not too bad. It's maybe 100 lines of code or something like that. And it just basically helps out with the, creating the whole, well, what we would call in ZIM the stage, you know, and all that kind of stuff for sort of the framework for ThreeJS. ThreeJS isn't as bad as 2D, Box 2D. Box 2D is rather verbose. ThreeJS is actually fairly tight and moderately straightforward. Okay, so, oh, well, here we are in some code here. We're going to be bringing in a phone model. So if we scroll up here, there's the call to the ThreeJS on the ZIM CloudFront server. So, well, it's Amazon, and it's the same place where we store ZIM. That's version 82. Depending on what happens, I may update that on occasion. And then here is the helper class that we just looked at. So we're bringing both those in. We're sitting inside of ZIM 4.6.0, which is the latest version of ZIM. And that is the version that has this swiper that I'll show you in just a second. We're in a fit mode. And we come in here, we're going to start by making a var 3 is equal, well, let's call it display, because it's sort of what we're going to be displaying. Display is equal to a new zim.3, like that. And then we'll drop to the ZIM duo technique to pass in some parameters to that. So the first parameter is a reference to the frame. The ZIM frame, which is frame, and that helps with scaling and a few other things like that. Like, I think what we're doing is we're overlaying another canvas, a second canvas on top of the first, and so forth. So let's carry on. We give that a width. So what width will that thing that we're overlaying be? 500. We're going to show a phone, and we can sort of position the phone inside that. You can make this bigger or smaller depending on what you want. And a height, like so, of, say, 800. Finally, we'll pass in the camera position, like that. And that will be a new ZIM, ThreeJS this time. So now we're going out to ThreeJS, and the ThreeJS namespace that we've been using is capital
3 dot vector. It's a vector 3 as a matter of fact, and we'll make it 0, 0, 400. So what this is it's saying, hey, the camera, by the way, you can pass in information about the camera, like what type and stuff like that, but we'll just use the default camera and a few other defaults here. There's more that we can pass in here, but this will certainly get us going. So this is a vector, and it's got X, Y, and Z. So anytime we're placing things and stuff like that, or quite often within ThreeJS, you're dealing with a vector. Don't be too scared of it. There's X value, a Y value, and a Z value. So what we're doing to the camera is we're not moving it all in the X-axis. So imagine that we're looking at a scene. We're not moving it in the X, left and right. We're not moving it in the Y, up and down. We're not moving the camera up or down. But we are moving it in the Z, and positive Z is out towards you. So we're moving the camera back so that we'll be able to see what we put on the scene. Okay, so that's how we start that off. Now, we may or may not have WebGL, so we want to just do a little bit of a check for that. If, and this isn't an event, but it's sort of where it's like an event sort of success. It's just inline, so we don't have to worry about it. When we make this, if that doesn't make properly, we'll know immediately whether or not we've got WebGL, for instance. Now, this is almost unnecessary if you're working with ZIM, because I don't think that there's any Canvas code out there that doesn't have WebGL, but I could be wrong about that. So otherwise, there's no WebGL. In fact, it very well could be, but it's getting more and more rare as we go. And then in here we could say else, and we could show a pane with a message. You know, for now I'll just zog a message. No WebGL. Okay, you could put a sorry message or something like that. So it's inside here where we'll be doing our coding. And let's see, one thing that we get is the display gives us a scene, a display.scene, and we'll also get a display.camera and a few other things like that. But display.scene is where we're going to be putting everything, and so we'll shorten that. We'll call it var scene is equal to display.scene, much like in our frame up here. Frame gives us a frame.stage, but we don't want to keep on using frame.stage.addChild, etc. So we just shorten that to stage with the local variable. We're doing the same thing with the scene. So this is how we put stuff on the ThreeJS canvas. And now we've set it up so that canvas is held within a CreateJS DOM element, it's called. It's a way that we can overlay traditional DOM elements on top of CreateJS and ZIM, and therefore have some control of them, like the alpha and stuff like that we can control on the DOM element. What we're going to be doing is we're not really going to be controlling that DOM element, but rather we're going to be using JavaScript to control the properties of ThreeJS. Now the problem is when we've got two canvases, I haven't figured out how to interact with both of them at the same time when they're over top of one another. So you've got one or the other. You could, in theory, run a bunch of 2D animations in ZIM and have no interaction, and have only the interaction in the ThreeJS with traditional 3D stuff. That's possible. You could put the ZIM over top of ThreeJS and control animations with JavaScript, not with the mouse. So we're talking mouse control here. So in other words, when we put ThreeJS over top of ZIM, if I were to activate ThreeJS's mouses, I could not then use a mouse on the ZIM canvas, and vice versa. So what we're going to do here is we're not going to control ThreeJS with the mouse. We're only giving the mouse control to ZIM, and then we'll control the ThreeJS scene with JavaScript. Okay, so next what we're going to do is bring in our model. So we'll store it in a variable called phone, var phone,
we'll just set that up or declare it, and then we use a loader. So var loader is equal to a new, oh, not Zim again, sorry. This loader comes from ThreeJS, and it is an object loader. Now there are other loaders as well, and loading images are loading models, a bit of a pain in ThreeJS. You know, I just spent 2 or 3 hours trying to get various models to load using various different types of loaders, and I couldn't get them to load. I eventually bought a model, this phone model, which is good, and that worked just fine. And then I went to the new version of ThreeJS, and then it didn't work with the JSON parser or JSON loader. And so in the end, I did get it to work with the object loader, but I could never get materials to work. So I tried for 2 hours to get, like, well, I got materials with colors in them to work. And there's some cool things that I'm going to show you where we've hacked into that, and we can change the color of the model. And that's sort of where I'm getting to in this capture. But first, let's just imagine that it all went easy, which it actually did, I suppose. Once I got to the object loader, this is fairly straightforward, and we say loader.load, and the models work best, it seems, anyway, as far as I can tell. There's just, you know, a whole history of model problems, but people who sort of really know what they're doing don't seem to have too much problem, I guess. But heck, you know, I was trying 3 different models and getting 3 different errors that didn't mean anything at all. And, you know, it's just like, oh, headache. And I know people want to bring them in from SketchUp sometimes, and then they don't work. And it's just like filled with problems of all this stuff. It's like, oh. So anyway, you know, 3 or 4 or 5 hours later, so just be warned that you may get lucky, you may not. And this has been my experience with 3D for the last 10, 15 years. You know, I've done several different 3D systems, and it's always just a pain to get textures to load or whatever it is. So anyway, we do have, let's just pop on over here to the left, we do have in the assets a model right here, phone.json. So that's the native model for ThreeJS, and now there are exporters from Blender and stuff like that. So hopefully it's just getting easier and easier. So we're going to bring in this file that's in the assets. So we say where that is, assets / phone.json. And JSON, you probably know what JSON is. That's just an object that has been made into a string, basically. So the whole thing can be passed as data quite easily, and then you parse that and turn it back into a normal object, and that object can have inside it things like other objects, and these are object literals, that is, arrays and numbers and strings and that kind of stuff. Oh, but no fancy objects like a date object or you know, like a ZIM slider or something like that. It's only sort of data or so. Okay, so asset / phone JSON, and then when that comes in, this is the callback function. So this is what the function will call when that is ready, and we collect in that an OBJ, and so that will be the model that we put on the scene. So it's actually quite straightforward. We then take the phone and we'll set it equal to that, just so we have reference to that later called. If we don't do that, then outside of this event, we don't have, well, it's not quite an event, but outside of this function that's being run right here, we don't have access to the OBJ because that's a parameter that's coming in there. So we've stored or declared it outside phone, and now we're assigning it. So we'll have outside reference to phone if we need it. We may end up doing everything inside of here anyway. Okay, so, but not only that, we add it to the scene. So scene dot add OBJ. So that's very nice. You really can't get too much simpler than that. Hey, call the thing. When it loads, take it and add it to the scene. Brilliant. That's great. Some of the other loaders are a little trickier than that, where you then have to construct things that you've brought in. So you know, this one's pretty cool, and it comes right in ThreeJS. Some of the other loaders are external, so you've got to make sure you find them from the GitHub site and then call them in up top. Okay. All right. So there is
there's that. So we should see something on the stage. Do you want to see it? So save that. And we open it up in a browser. And there she be. There's the phone model. Okay, no interaction on it, but it's in there, and that's good news. Alrighty. So next, we will, why don't we try positioning that, for instance, because it looked like it was up a little bit high. So we can say phone dot position. All the positions and rotations in ThreeJS are done on a sort of an intermediate object there. So this is the position object, which is a property of the phone, and then we would say .y, or we could say .set and set all three at once, but we just want to move it in the y, so we'll say .y. And it looks like we want to move it down, so that's negative, so we can move it down 100 or something like that. Okay, and let's see if it moves down. And there she be. So it's pretty good. It's roughly centered. Now I think what's happened there most likely is I'm not quite sure. It depends on where they made the model, its origin and all that kind of stuff as to how that all gets positioned, or perhaps that was centered. So we had a certain height that we gave it, which would be just sitting right there, and there it is, in that. But we now moved it down. Now we can move it closer as well. I suppose we'll get to that. For now, you know what? I wouldn't mind adding some lights. How about we add some lights? Because that phone, I see it, but I know that the phone can look a little bit nicer than that. So for lights, there's a few different types. There's a point light, directional light. A directional light's almost like the sun. It's from far away and just shines all the light rays are parallel. Let's put in a directional light bar. Light that will just, in general, light our scene is equal to a new 3 dot directional light. There she be. Directional light, and we'll pass in white. Now the color scheme for ThreeJS is hex is okay, or but it's got to be a big long hex number. So this is how you do a hex number: 1, 2, 3, 4, 5, 6, like that. So that is white. And we used to do this all the time in Flash too. I kind of wish that we would do this in Create.js and ZIM and we sort of do it in the world of HTML, I guess. But this is nice because that's actually a number. Whereas if we were to put a number sign in there, that's no longer a number. You see, we've got to treat that as a string, like so. So anyway, that's a number. We're going to deal with colors in a bit because, as mentioned, I was going to show you that we can dynamically change some of these colors. So that will come to play in just a moment. So there's a directional light, semicolon, and then we position that, light.position. Do you remember how to position? Position. This time we'll use .set because we're going to position a few of these things. And we'll set this light to be no movement in the X, but we will lift it up a little bit, 250. I don't know if it matters too much actually for this one. So directional. And 100 back. So this is back from what we placed. What we placed is at 0, 0, 0. Unless we were to change it. Well, I guess we did. 0 minus 100, 0. And then we better add that not to the stage, but to the scene. So scene.add the light, please. Well, hey, it's not too much difficulty to add a second, and that will make it glint nicely. So let's add a second one here called a point light. Point light. Like so, light 2, I guess. Light 2, light 2. And this one will move off to the right a bit just so everything's not so totally even. So we've moved it off to the right in the X a little bit, a point light. And let's take a look at our scene now. You ready? Well, what do you know? So you can see that our light is sort of glinting off to the right. We've got some general lighting, which looks, like brings up the color. Oh, wow, we can see color, which is cool. So there we are. Now it's blue. The original model wasn't blue, but I went into it and I started hacking it in a sense. And I'll show you some of that hacking
where I got to in another feature, which we'll do just after the basics. But for now, we want to spin that. We want to sort of swipe on it so that it will spin around the axis. So it's going to spin around this axis, which is the y-axis. We can also try around the x-axis to tilt it back a bit. And we also might want to show how to make it bigger and smaller. So tell you what we'll do. We'll make it so that when we swipe sideways, we spin it, and when we swipe up and down, we'll bring it forward and backwards. Sound good? Okay, now those are things that you could do quite easily with the orbit control. Orbit controls there's various types of controllers in ThreeJS. Sometimes they're rather mystical, I found anyway. I've done this stuff for a long time, and I go to look at controls, and if I can't understand them, I'm kind of going, why can't I understand these? But anyway, so you probably get the same feeling as well when you look at some of these things. So quite often I'm just left with the basic controls because I don't know what these other things mean. I suppose I could get educated on them. They must make some sense. Perhaps that's how it is with you guys with ZIM as well. I know what all this stuff means. It's easy. Isn't that easy? You probably come in and go, oh, what does that mean? So we're going to see some examples of that right here. Let's take a look at a swiper. So var swiper is equal to a new zim.swiper. Now, the first thing is, what are we swiping on? And this is now documented in ZIM 4.6. So the first parameter is, what are we swiping on? Shall we? I'll just keep it direct. What we're swiping on, we could make it the stage. Or if we wanted to, we could make a rectangle in behind the phone that is roughly the same size as the phone and swipe on that rectangle. We'll make that rectangle, the same color as the stage, or same color as the stage. So that's frame.color. And then we wouldn't be able to see the rectangle, or we could drop its alpha down. And then we swipe on the rectangle. But in this case, if the only thing on the stage is a model, you sort of may as well just give them an overall swipe on the stage there. Next, you need to pass in what object holds the properties that we're going to change. So we're going to be changing the rotation around the Y. And if we take a look at that, oh, we don't have, why don't we hard code in? Tell you what, I'm going to move these just up above the lights. We're done with those lights. I'm done with them, I tell you. And so up here, so there's our var swiper. I better comment this out just for now. Let's take a look at rotation. So phone.rotation around the y-axis equals, say, 20 degrees, except rotation in ThreeJS is in radians. So this is times math.pi divided by 180, like so. Okay, remember your radians. And let's take a look and see. This should rotate the phone, like just spin it a little bit. And there it is. Okay, rotated. So we're going to be adjusting that rotation as we swipe. But note that that's a very small number. Okay, shall we zog that? Zog phone.rotation around the y and just sort of see what that number comes to be, because look, math.pi, that's 3.1416 divided by 180 makes it quite a small number. So just recall that radians is small, and f12.3. So when we go to swipe, which is here, well, I'm getting slightly ahead of myself. Let's just carry on with our swiping. So we're wanting to change this property, and what object does that property belong to? It belongs to this one, which is the way we get at it is through the phone. So we have to say phone.position. Usually this would just be one object in here, but in this case, to get to the position, we have to go through the phone. Okay, so that's a reference to the object that's going to hold the property, and that's a reference, so it's not a string. However, the property is a string, so we then say the Y property. This is sort of how we go about it with ZIM animate as well. You pass in objects that you want to animate, and the property names are like that, and the target is like this. Okay, so we're swiping on the stage. We're wanting to change the phone's position's Y property. And the next parameter is the sensitivity. So for every X pixel that we're moving, how much of the property do we want to change? Does that make sense? So this is not an absolute property changer. This is a relative property changer. So you just kind of, so it's a little bit different than something like a slider, whereas if you move to a certain position, your value that you get out of that will be a certain position. In this case, we're every time I swipe, I'm continuing to rotate. So it's not an absolute value, but it's a relative value that we're getting. So if I move 100 pixels, how much do I want this to rotate? Well, we saw that, I'm going to be moving 100 pixels in my swipe for sure, maybe even 500 pixels. And we don't want to change this by very much. So you just kind of take a stab at it, 0.01. You might try a few different things. If I put in 0.1, I'd be moving this way too quickly. And I look at it and go, oh no, that's too quick. And if this is still too fast for me, I can even drop it back to, something like that. But let's try 0.01 in terms of its sensitivity, like that, and try it out. And we refresh here. Oh, something didn't work. Swiper is a swiper on the stage. Swiper is a swiper on the stage. Let's see, we're doing the Y, we're rotating around the Y, 0.1. Yeah, all that looks good. What do you think it is? Oh, I should check to see if we had an error. Oh, I did, didn't I? And we didn't see an error. So we save that. No. Oh, you know what? It's going slightly up and down as I go left and right. Why is that? Oh, I did the position. Oh, I'm such a dingbat. We're wanting to do the rotation. My apologies. But I did see, and movement is not in radians. So let's just go back to that for a second. We were doing movement there, and oh well, darn, I must have saved it. Oh, there it is. Look at that. Isn't that beautiful? So that's beautiful. However, when I went back to, let me just show you position, because if you wanted to, you could move position. This is position in the Y, and here's kind of what was going on. As I swiped, I'm looking at this going, what's it doing? But you can see that it's slightly moving up and down. First of all, if we're moving left and right, we probably don't want to change the Y, but we could change the X. And obviously we want it a little bit more than that. And let's just try a 1-to-1 ratio, so a sensitivity of 1-to-1. Whoa, and you can see that going right off our designated canvas area at roughly a 1-to-1 ratio. Anyway, that's not what we were wanting to do with it, but I mean, somebody might want to do that. We want the rotation, and we want to go the rotation around the Y, because the Y-axis goes up, and that's what we're spinning around. Not a 1-to-1 ratio, because this will just go absolutely bonkers. Do you like that? I mean, maybe if you want to spin a basketball or something like that, but so that's why we've dropped this down. Even at a 0.1, this is the sensitivity that we're playing with now. Even at a 0.1, it's still pretty darn quick. I just move a little bit to be able to rotate that, and I can spin it quite quickly. So 0.01. Okay, so 0.01, and yeah, that looks pretty nice. You can almost get, yeah, you can get a spin if you do a nice long one. Do you like? Cool, huh? Okay, so that is the swiper. Why don't we try one more? Should we do the scale? So copy that and paste it here, and we'll call this scale. We'll be going on the stage again. We won't be doing rotation. We're going to be doing something different. So let's just comment that out for a second. And we'll come up here, and we shall do the, not the phone, but we're going to change the camera position. And the camera position is here in the display. We get a reference to it in the display. So we can say display.camera. we've already changed this. Do you remember? Camera dot Z. We'll use the Z, and we'll set that equal to something else. This was setting the Z of the camera, 400. So let's try 300 and see what happens. So what should happen is when we were at 400, the camera was back far from our object. When we go to 300, the camera should be closer, and therefore our object should be, there it is. Just close that down and refresh. Nothing. Is it bigger? I don't know. I couldn't quite tell. Should be. Did we save it? The Z. Well, let's try 200 and see if that makes a difference. Sitting in here, and no, I'm not seeing anything. So what's our problem here? Let's see. We've got a display.camera position. Oh, we forgot. Okay, so looks great. Display.camera Z, but remember it's actually the position. Oh, aren't we great? Oh, what a day this has been, huh? It's pretty early in the morning. Good morning, everybody. So display.camera.position. How much fun is that? .z. Yeah, I mean, I suppose that's... Some of these things are like that. You know, ThreeJS is a bit like that. Because it's 3D, you've got multiple things inside, and you know that's a very modular and object-oriented way to do things, I suppose. You may have noticed, if you've been working with ZIM at all, that we pretty well flatten ZIM as much as possible anyway. So we don't come across this all that much unless we're actually chaining something. Unless we want to do that. Okay, so display.camera.position.z, and I suppose we could always assign this to a variable, like say something like var camera equals display.camera, and then that would take away at least one of those. Let's see if it works. So we've got 200 now. We should see it be bigger. It is indeed bigger. And now let's drop that back to, well, let's try 250 and see if it fits on the screen there. So we refresh this. Not bad. It kind of just touching the top there. So if we're going to move up and down and scale this, this might be one sort of end of the scale that we want, and maybe the 400 would be another. So that's sort of a good way to do it. You could kind of plan on what you're scaling. The other thing we could do is just put it in there without any limit. You'll see we're about to see that the swiper can have a limit. So let's just put it in there without any limit and see how it goes. So instead of the phone.rotation being the object, now it's all this thing right here that is the object that we're working on. And if we were going to use the camera more, then we might want to put that in a variable like we did the scene, var camera equals display.camera. Should we do that? Yes, well, var camera equals display.camera. I think there might be one other line coming up with the camera in it, perhaps, or not even. But anyway, there we go. Now we can just say camera.position, and we avoid making that error I made before where I forgot to do position because the bloody thing was so long. Okay, there we go. And is it position? Yes, but position in the Z. And our sensitivity will be more like 1-to-1, sort of. You know, we're going from 250 to 400 here, so you know it's close anyway. And let's try it out without any limits on it. So we save this. There it is. And as I push forward, up and back, let's see, I can spin. No, that's something's, oh, I know what it is. Look, it's zooming based on our left and right, based on our X. So that's the next parameter. The next parameter is, do we want horizontal? Horizontal is probably the more common one, but often when we're working in 3D, we want both. In this case, we need to make a swiper for each of them, which sort of makes sense because most likely we're controlling something different. Okay, so in this case, the next parameter is horizontal and defaults to true. So we want to set that to false. And now I think we'll get the action that we were expecting. So yeah, spinning that way, and then just get the front of it here.
If I push forward, too big, push back. So we're getting sort of, this is unlimited, so I can, hey, see you later, phone. But note, I have to kind of swipe each time, and there, it just went past our camera. So right now, into the camera, whoop, past the camera, can't see it anymore. So we want to put a limit on that, and we can do that with the next two parameters, our min and max. The other thing, let me just try that again. Refresh. I pick that up. I want to maybe push that away and pull it towards me. It depends on, on which way you want. I don't know if there's an established set way of doing it, but I think it's working opposite. If it's working opposite, just throw a negative sign in front of the sensitivity. So we refresh that. Now I pull forward and push back. Yeah, that seems more natural to me. I'm pushing it away and pulling it towards me. Push, pull. Okay, so that was done just with, and same with this thing. If we wanted to, I could have swiped to the left and had it spin to the right, but I don't know why I would do that, but you could do that just by adding a negative sign in front of there. All right, back to the limit. So our limit will be a minimum of whatever we said, 250, and a maximum of 400, like so. So min and max are the next parameters if you choose to put minimum and maximum on there. So I push and I can't push anymore, and I pull and I can't pull anymore. So there's, yeah, I think this was the spin just reaching. See? So that's working. Cool, huh? And basically, that's similar to the types of controls that you can get in ThreeJS. And here they are operating in ZIM in a fairly easy way in ZIM 4.6. So have a read on the docs on that if you so need to. And I'm sure you can imagine how you would then rotate around the X if you needed to. Okay, let's just show you quickly. That's rotating around the X. And refresh. This is roughly what it would look like. There's bringing it towards me and back. Okay, so you might want to make that much less, like say 0.001 like that. You might want to put some limits on it as well. Oh, that's making it bigger, so that's, yeah, I can move a bit more and I'm tilting it left. Isn't that light nice though? The point, yeah, it kind of clears it out. Okay, so that is what I wanted to show you in general here. We've brought in a model. Well, before that, we created our helper object. We found that we have a scene and a camera from that. We brought in our model, loading in a model. And now we're going to take a look at how we can customize that model. But rather than building it live, we're going to go to an example that's already been created. And that's this one right here, the 3.html. We've done a few things differently in here, but let's just take a look and see what this looks like. So we'll open it up in a browser. There she be. Let's F11 that. Okay, so same kind of deal where I can swipe and spin this thing, and there's the phone. We've added a dial, and the dial can also spin it like that. And then the zoom is done with a slider. So we're using some ZIM components to control that, similar to how we controlled it with the cube. But here's something exciting, a color picker. Boop. Ah, neato, huh? Isn't that neat? And there's that little tilt, like when I push forward, I got a little tilt there. Excuse me. And this changes the color. Cool, huh? Gold. The old gold phone. There's white and black. Also, if I press there, we get the white screen inside there. Bloop. And even if I press like that, but if I turn it, I can't press. What do you think? Nice, huh? So that's some of the extra things. Now, what might happen here is you could put tickers on here and rotate this at specific rotations. If you're scientifically, you're in some sort of crime lab app or something and you wanted to have more control over things, rather than just kind of spinning it around, you might want, and certainly color pickers are handy. So we're going to go in and take a look at how this was created and how we hacked the model to do that. All right, excellent. So you got the basics.
And if you combine the basics that I just showed you with some of the, how to get a cube in there or get the geometries in there and apply mesh or the meshes and the geometries and the materials, that's all shown in the cube example. Then you're on your way to using ThreeJS. So it's kind of cool. All right, let's close this down and pop into the code and see what we did that was a little bit different. So we could be here for a touch. We've got about another half an hour, maybe 15 minutes. So sit back. There's a lot of really cool things in here that will certainly help you, and we'll have fun taking a look through. Sound good? Okay, let's do it. So same as before, up here we brought in our ThreeJS. Oh, this one's a little bit different, and we brought in Pizzazz. So just a note there, we've got Pizzazz coming in, and that will help us with some of the styling. Okay. So we create our display. We've put the camera 400 back. When our display is successful, we make our scene. Now I've got a zog in here of this thing that we're doing to get colors into numbers. So we have a bunch of colors that are in this format. For instance, frame.lighter or frame.green, etc. So how do we turn a color like that into one of those other numbers that ThreeJS uses? And here's the technique that I've used. If you put the color in front of a slice, it takes off that. So then you're converting this hex number, a base 16 hex number, into a decimal number by using this technique right here. So we're going to zog that and see what that turns out to be. Oop, the number sign in the wrong place. As a matter of fact, 0 is sort of a bad example because that's just going to come out to be 0. So 1, 2, 3, 4, 5, 6. Does that look like 6? Yeah, so we save that. And let's take a look here. We'll open it up in a browser and open up our panel, F12. And there it is right there. Blah, blah, blah. We've also got a whole bunch of pizzazz things coming in. Why don't I just drop on down there. See, isn't this fun? There's pizzazz. And I'll take off the list shape so we can zog things a little bit easier. Okay, close your eyes. Yeah, sometimes when I scroll, hopefully you're not watching this on some big screen in an auditorium filled with thousands of people. Well, actually, hopefully you are watching it in a big screen with an auditorium, thousands of people, yes. But anyway, my apologies for scrolling. I probably just gave you vertigo. I'm falling! All right, so that was the zog. Did you see the number? I don't even know if we concentrated. I was so busy talking to you about the other thing. There it is right there, 16 blah, 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 so some big, huge number. And those are the big, huge numbers that we're going to find in the colors of the materials in our model data. So we're about to get to our model data. Oh, hey, it's right here. Phone data, dot materials, okay, wow, what is all this stuff? And there we are anyway, setting a color. So let's show you the model, shall we? Now I've got two models in the assets. One is called phone.json, and that would be how you load it in from an external file. So all that is JSON. I'm going to open up this one right here, and what this one is a very large file, like a 3 megabyte file or something like that, filled with actually it's fairly well laid out. It's as you can see, it's JSON. It's relatively readable. There's the geometries that are available, and down somewhere here we're going to find the materials that it uses. Still scrolling, there it is, materials. And what we've done, I should have, and I mean, look at this thing, lots of data. And by the way, these lines that you're looking at, some of those lines are really, really long. If we scroll down here, you're going to find that there's maybe it's certain geometries are really long. These guys are lots of data. So sometimes it's not too easy to come in here and parse these things. But luckily, the materials are relatively easy. But up at the top, if we can get to the top, up at the top, what we've done is when it's a JSON file, it just looks like that. So it's from the bracket on down. Okay. When we want to use it, I'm just going to assign that to a variable. So this is what we've done, is we've put it into a JS file and brought in phone.js into the top of our 3 document here. And that gives us a global variable called phone data that holds our JSON information. Okay. So we can just parse that directly. Let's see. What we've done is said, hey, phone data dot materials at 0. Oh, pop on back out to that stuff. Crap. Phone data. What was it? I want to just show you the materials. So scroll on back down to the materials. Data. Don't we love data? Did you read all that? So here's materials. It's direct. So we go phone data dot materials, and then it's an array. And it ends way down here where it's got 18 different material objects. So within there, there's an object in each one. So there's one object. Here's another object for our different materials. And you can see that our materials object has some properties, including color. Now it also should have the ability to put in a mapping color. Like there's different types of ways to map to, you need a better word than that. I can't remember what it is right now. But you could map to an image. So we should be able to also add to that an image. And when we load the model, an image would show up for this material. But that is what I couldn't quite get working. But at least I found the color. So here's one of the colors. All right, and what we're doing is we're hacking that color to change the data for the model. And then we're just remaking the model. So if we want a different color, we get rid of the old model, take it off the scene, load a new model, or parse a new model, and then we get a model with a different color. So, ooh, isn't that cool? Let's take a look and see how we did it. So in this case, we're adjusting the starting color of our data. So this is our phone data. And what I did is I just went in and I manually changed in that data. I changed the colors in there and I went to see what would, well, actually, maybe I just hacked it here. I changed these things and found out what would happen. So right now we're setting a bunch of them to lighter because our phone starts off, as you can see there, our phone starts off at this lighter color, which is almost white, but not quite in ZIM. Okay, so what would happen if we went frame.green, greeny, frame not greeny, frame dot blue, bleh, and frame dot pink. Okay, so this should change different parts of that phone, the colors that we're wanting to change. So if I refresh this, there it is. So now let's just make that a bit bigger. The button is blue, the front face is green, and the back is pink. Oh, so you can see how you could customize something, huh? And then we're just connecting up that concept with the color pickers. So as we change a color picker, we hack into the model data, change the colors at those locations, and then get rid of the model and reload it. So let's see how we are loading the model there. First, we better undo that. And they're all back to lighter. So far, so good? Yeah? Okay, down below, we set up a rectangle this time. So we're not quite getting to the changing of the color yet, but we'll get there. So we've set up a rectangle of 500, 500. We've set it to be the frame color. Frame.color is just the color of the backing of the frame. If we want to set that to pink, so that we can see it, that's us setting the swipe rect. And there it is. There's a rectangle that we're swiping on. So note that we can swipe there, and we can't swipe here. The reason for that is if we were to swipe here, as I do that, it actually, well, as I do that, it's moving down. But if I do any of these other things and swipe over here, it would actually be swiping as I'm using various other interfaces. And I didn't really want to do that. Ooh, some of those look ugly. White with pink. Okay, now there's probably a background color being put on the model as well. I believe that there's a setting when we set up our scene to do that. I'm not exactly sure. I can't remember exactly how that worked, but that's all right. You can take a look at that. Okay, so cool, huh? But we don't want to see that swipe rectangle, so let's reduce it. And that is where swipe rectangle, or not reduce it. We could change the alpha of it. There's actually a clear. Let's see if clear allows us to swipe. Are you ready? It'll be interesting for me to find out. No. See, isn't that interesting? So if there's no pixel colors, it's like it's just not there and you can't use it. So you can reduce the alpha on it by setting your own color there, but instead I've just set it to the background color of the stage, and now it's gone. And since it has a background color, we can swipe on it. Okay, next. Load in the phone model. So it's the same loader as before, but this time we're using loader.parse instead of loader.load. You would use loader.load to load in a JSON file from the file itself. But we already have the JSON data inside of phone data. Remember, that's our global variable that is holding that JSON data. So we're saying, please parse that data and turn it into an object to put on the scene. Okay, so the rest of that stuff's the same. We positioned it as we had done before. Now we've got a ticker, we'll come back to that, and here are our swipes. So our swipes are pretty well the same before, except we're swiping on the swiper rectangle, so that rectangle we made, rather than the stage. Okay, and there are those settings that were similar to before. Now in this case we're rotating around the X when we swipe up and down. Up and down is false. It's not horizontal, up and down. There's that small amount just to move the X a little bit. And look at the max and min on that too. Right, so that's the minimum rotation and maximum rotation we're allowing to get that kind of just, hey, let me rotate you back a bit and rotate back up to 0. Okay, just to get that. The glare, I like the glare that you get when you pull it back and forwards like that. It's nice. Okay. So next we've got, we can come back up and talk about what's in the ticker then. So the ticker is running constantly. It's a ticker function that we've added here. Display.camera.position.z. It looks like we have not put the camera into the variable camera, or display.camera into the variable camera. No big deal. Okay, so position Z. We're doing something with the position in the Z, or Z, or whichever it is. I'm American Canadian. I am Canadian now. Woohoo! Born in Hawaii, but live here in Dundas in the freezing cold at the moment. So slider.damp.convert slider.current value. Here's one of those cases where I say, oh yeah, you know, like ZIM is so easy. And then we come in and we look at this kind of stuff and we go, really? Okay. But hopefully, this is actually quite wonderful what's going on here. It's saving us some speed. This is the slider. So we're using the slider to change the position Z. We've seen that before. Let's take off the damping. Oh, before I save it, yeah, okay, I'm taking off the damping and we refresh here. Now when we use the slider, it's like immediate action. Whomp, 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 whomp. Okay, and a bit jittery too. So whatever I'm doing with the mouse is being directly done on the camera zoom there, or the camera position. So let's undo that, put back in the damping. So now we've put back in the damping, and how we use damping is just down below when we made the slider. I just said var slider damp equals zim.damp. That's it. That's all you need. Okay, so there's the damping object. And now up here, instead of using the value directly, like we did when we commented this out, we're going to convert that value with the slider damp. And what that does is it doesn't use the value directly, but rather uses a certain percentage, or like 0.1 towards that value. So this is what happens when we refresh here. Nice.
and it's as smooth as butter. It's just beautiful. So you really have to use it. You got to use damping. It's just lovely, and that's what's giving this smooth motion as well. Now, along the lines of damping, let's just discuss that. This is damping just fine because we're changing the rotation, and damping, as I spin this, the damping is heading towards that value and slowing down, because as it gets closer to the value, the percentage is slower, so that, or this percentage is smaller. Okay, you know, if you've got 100 to move, then 1% of 100 is, you know, whatever, 1. If you've only got 1 to move, or say 10 to move, 1% of 10 is is smaller, like 0.1, and that distance slows down. So in one case, it's moving quickly towards it, and then as it approaches the end, it slows down, and that's the principles of damping. Now, what happens with the dial here? Unfortunately, we can't do that, because the dial goes from 0 to 360 in radians. Okay, so if we go like this over to this side, it's going from 0 to 360 or 350 or whatever next measures it at, 0 to 300 and something. And what happens is this goes, okay, I was at 0, I'm wanting to go to 300 and go spin. So it would damp, it would spin it and go brrr, and spin around. I know, I tried. It's kind of like, oh crap, that's right. And so we could make it work if we make the dial. It's easy to set a ZIM dial. As a matter of fact, by default, I don't think it wraps. So we could set a ZIM dial that starts here, goes to here, and that's it. It won't go any further, and you have to come back. But that was so unnatural to be here and say, okay, I'm looking at this thing. Oh, great, there it is, stop. Oh, I want to, how do I, you know, and have to go back rather than just sort of continue on. So I did give it some thought and couldn't really come up with a quick solution, or any solution really, to handle that problem, short of, you know, I don't know, like short of modifying the dial maybe to, anyway. So that was difficult to do. So instead, I said, all right, well, the dial will be kind of exact and precise in its movement, but at least this is nicely damping. Okay, so we're going to see some of that in the code. It makes it a little bit more complex because we've got 2 systems here that are controlling the rotation, and we have to make them sort of pay attention to one another. So there's a couple extra things that need to be done for that. All right, slider damping, quite easy. Alrighty, let's carry on. So that was the positioning of the Z, and this is happening in the ticker. Anytime you do damping, you've got to put it in a ticker. You know, you might think, oh, ticker.onChange, let's change our position only when we change the ticker. Well, it looks smooth while we're moving, but as soon as we stop moving the ticker, as soon as we don't, or sorry, stop moving the slider, then the damping stops, and it just sort of like, it's going smoothly, and then all of a sudden, chop, and it doesn't even go to where it's supposed to go yet. So any damping needs to come here in the ticker. All right, so what else have we got? The underlay dot scale. Okay, what we've done is to position that little dot to turn off and on the screen. I know that's a home button, but this little dot, hang on, let's show you. To position this little dot, what we've done is made a rectangle in behind that's the same size as the phone and put a dot on it. We don't really need to make the rectangle, but I was just kind of setting it up so that if you wanted to, say, put a whole bunch of icons on here, you could map those bunch of icons to this 3D model. Now, as we change the slider, we're changing the scale of the model, so we need to change the scale of the rectangle in behind. So take a look at where that button is. It's here right now. Click, and it's working. Let's just change to a different color. What color do you like? Kind of like the pink, I think. Anyway, I press on that here, and it works. And I bring the scale down to here. And now it used to be here, but it's not there anymore. It's up here. So that's because we're scaling this, what do we call it? Let's go take a look.
the underlay. It's not really an overlay because the ThreeJS is on the top, so I called it an underlay. We're scaling that as well with the slider. Okay, and we're using a proportion to do that as well. Let's not go into that. You know, I can't quite even remember the nuances of that, so we'll just leave that. But the proportion works in a similar way. Well, not quite in a similar way to damping, but there is such a thing as even a proportion damp. And it's basically the slider is moving a certain amount, and yet we don't want to scale totally equal to the slider unless we set the slider up. Oh, right. Yeah, I guess they must be two different things. One is moving the cameras. Yeah, the slider's primary goal is to move the camera's Z position. It's not to change the scaling of the other thing. So we're using the same slider, so we had to adjust that slider value to set the scale properly. And therefore, we rolled a proportion to do that. That's a fairly simple equation, but the proportion class in ZIM just takes away any of the thought to it. It's pretty easy. Alrighty, back again to here. We've got the display camera look at. We don't really need that in this case, but it's handy to have in here just to remind us that we've got this. If ever we're moving the object in the scene, we might want the camera to turn and look at it. So it doesn't really move the camera anywhere, it just sort of rotates the camera to look at the scene, and that's usually what we want. But we could comment that out, and everything here would work the same way. And then a dial dot current value is equal to, oh my goodness. Okay, right. So the dial's current value, that's what's positioning the dial. As I spin this, you see that bit right up there. As I spin this around, the dial is moving to the rotation of that. Now, that's a bit tricky because remember the dial's value has to be between 0 and 360 in radians. Okay, otherwise it will just be set at 360 in radians. Like if it goes above 360 radians, it'll just be stuck up at the top. If it goes below 0, it'll be stuck up at the top as well, because that's where both of those things are. All right, so what we've done here is we've taken the swiper's desired value. So this is kind of interesting. The swiper, if you want, the swiper is responsible for damping motion, right? But it does have a property inside it called the desired value. And we've exposed that so you can do something like this. The desired value is where it's trying to damp to. So that's almost like the real value it's supposed to be at, and it's actually moving to try and catch up to that. So we can ask for that if we want. So we take where it's trying to get to, because we're just going to put the dial directly there. We add 360 to it. So we add 360 degrees. We'll just call this 360 degrees. It's in radians, but for now we'll just imagine it 360. So we add 360 to it, and we divide it by, oh, I don't even know if we need to do that actually, and divide it by math dot, or not divide it, but modulus by 360. So what this situation does, I thought by adding it, it always, oh no, it doesn't. I don't even think we need that. Shall we take it out? I thought by adding 360 to it, it would always keep it above 0. But if we keep spinning it to the left, it won't always be above 0. This is what was needed afterwards. So I don't even think we need that. Let's just try it. So we're just going to modulus the swiper by 360. Yeah, let's see if it still works. So we refresh that, and what are we doing again? We're seeing if this works just fine. Oh no, look at that. Did you see what happened? I went backwards. Yeah, I went backwards. So what that's doing is it's buffering the fact of when I go backwards to minus 360. So I just go to minus 360. Yeah, so we do need that in there. My apologies. Tricky, isn't it? So that was a technique that I remembered figuring out a while back. You know, I've been doing this kind of stuff for a long time. So if you haven't, you know, at least welcome to this capture. Now you know there's a little bit or something of a snag. Maybe it'll go into your mind at some point. So we're keeping that above 0 and doing that. So now when we go backward. Oh, I'm not moving that. Now when oh, it still doesn't work. Did I save that? Oh, yeah. Oh, no, it bounces off. What's it doing? I guess that's, yeah, I guess it's good. Maybe it was going the wrong way. No, it goes this way and it goes forward and comes back. Huh. Do I have a bug in there? I never even noticed it before. Unless I didn't save this. Oh, I didn't save it. So it's still that same bug. Okay, there we go. Yeah, woohoo! Okay, so there we are. Now, don't think I fixed the bug. I'm not seeing what I'm seeing. You know, I almost did that. It's almost like I can't be seeing that. It's still not working. You always have to admit to yourself when something's not working. In that case, it is now working. But I almost said, nope, I'm not seeing that. Isn't that funny? So there it is. With that technique of just increasing, I'm able to now match that up. All right, so that's obviously a little bit advanced and a little bit tricky, but it's a neat mathematical problem. We are keeping that. Like if it went too negative, then that wouldn't be positive. So so we always have to make, if I go too far, let's see, which way is negative? I guess that way is. Let's just make sure. Did it only go once and then bounce back? No, I think I just mishit it. Yeah, it's working just fine. Okay, cool, huh? Now let's see, where did we get to? Almost done. Set dot. The set dot was another little bit of a tricky thing in that what we decided to do, we could have, if we wanted to, you know how we mentioned mapping a rectangle? We should really see that mapping of a rectangle. Well, we'll get down to it. We'll see it down below. But as I slide this apart, I don't want that to be clickable now. I could have made it clickable there almost up to 90 if I wanted, but I decided to make it sort of like a 1/5 spin on each side it's available. So from 4/5 to 5/5 it's available. That would be like that. And from 1/5 or from 0/5 to 1/5 it's available. That would be like this. But if I spin back here, oh, still there. No, you know, we don't have it below. So we're basically, dot is what's turning that off, and it does it by just saying, hey, I don't want the pointer to be there, and then when we click on it, if the pointer's there, we let the click go through, and if the pointer's not there, we don't let the click go through. One thing that does is this area is dead right here, because that's the click area, and it's taking away from our swiper, and I think that's okay. And if we really wanted to, we could have made it so that instead of just saying get out of this click event, we could have removed the click event completely, and then on the back of it we could swipe at this location. You know, for this example I didn't do that. If it were a production example, I might. It would only take 5 minutes, not even. Okay, so that's set dot. Hey, we just got through most of the complex stuff, I think. There's the light and another light. I call them both light. Yeah, smooth move. Which is fine. We just set them and then don't do anything with them, but better adjust that slightly. So now we're down into the ZIM components, and we're about to where we find out how to change the colors. Yay! All right, it's been a long one, huh? So we're making a new color picker. We're passing in the colors. We've got one column in the color picker and a width of 70. You know, we can adjust this pretty easily. If it were 2 and we wanted them bigger, say, we could go 150 or something like that. We save that up and check her out here. Now we've got slightly bigger color pickers and 2 columns, maybe better for kids even if they were bigger. Now we used ZIM place to position those just down here. Color picker right here, place. So say we change it to that, and let me just save that. We can come back over here and refresh this, and then pick up the color picker and place it somewhere. If we wanted to put it over on this side, like right there, for instance, we can then look in our console, F12, and there's the color picker. So this has nothing to do with the 3D, but I'm just showing you some things here. I would pick that up. I would paste it right in here like so. I would comment out the color picker, save her up, and when I refresh this, there they are, right, right where we left them. Okay, pretty close to where we left them. I'm sure that that went right where we left them. It just adjusted due to the resizing or whatever. Okay, so we don't want that though. Control Z, and that is what we want. We are setting the color picker to start at frame.lighter, and then when we change, we're calling change color. And we're passing in the color picker's selected color. So that's how you get the selected color of the color picker, and we're passing that to change color because there's two things that have to change color. One is the color picker, and the other is that button that changes the screen color. So we're using the same function to do both those, but we're passing in one case, we're passing in the first color here, and the second case, we're passing in the screen color. And if we do have a color, then we're changing our material. So remember what we did up above? This time, whatever the color is we're passing in, we're slicing that. And we're changing those same materials, which goes and changes, it's kind of funny, that one, the one on the back, and the button. Okay, same deal there. So when I change this, that's what's happening. Now, it reloads a model, which we haven't seen yet. So just changing the data there won't do anything, unfortunately, because the model's been loaded, it's finished with that data, etc. So to actually make this change, we've got to remove the old one and load in the new one. And that's down here. There's the change of the screen that does that. So when we go to put a new model there, we want to make sure that it's at the same rotation. Now that will all be done quite quickly in the ticker for you anyway. It'll damp it to the right place, but sometimes you see a bit of a flash and so we're going to put it there directly. So we remember the last rotation around the x-axis and the last rotation around the y. We remove the old phone. We parse the data again. And all this stuff is pretty well the same, except we're going to set the rotation immediately, set the rotation of that phone to whatever the last rotation was. We set its position just like we did in the other one. We add it to the scene just like we did in the other one. So we're loading in the data again. And this is the data that comes from phone data. Hey, we just changed that. We just changed the colors in the phone data. And if we wanted to, so cool, we could change the material as well. And we could have icons take it to different materials in the phone. Would be excellent, and that would be all in the 3D world. Spin that. So scrolling down here, we one tricky little bit is the swiper is working on the phone dot rotation of the previous phone that we deleted. So what we're doing here is setting the target property of that swiper to the phone dot rotation, and that allows us to use that same swiper on a different object, because this is now a new object that's in. All right, cool. Cool, but tricky. I mean, you probably wouldn't have thought of that. You might be wondering, why is it broken? Why is it broken? Well, there you go. If you change your model, you've got to change what you're swiping in there, or what you're changing when you swipe. Okay, the dial. Bloop, bloop, bloop. Right, here's the dial. We add it, and we use the place to place the dial as well. And when we change, we're doing a couple things here. So we're finding the current value of the dial, storing it in val. Then we're changing the phone's rotation to that, but we are also changing the swiper's Y, because remember, both the dial and the swiper are controlling that rotation. And we're telling the swiper, do not try and damp to that. Just go immediately there. Otherwise, we start getting this, one thing controls the other thing controls, because remember, this is also controlling the dial, and the dial is controlling that. So unless we, as we move the dial, unless we immediately put that there, it's going to try and animate it using the damping. And when it animates using the damping, it then changes the dial. So you end up getting this, I don't know if they call that a race condition or something, but anyway, I don't think so. I think it's just, it's not good. So let's comment out that and see how not good it is. So if you ever see something like this,
Oh, darn, we still got double. This part works fine, but now I pick up the dial, and that's what I get. Is like, oh, I'm jitter, jitter, jitter. What's going on? Broken. Ah, help, help, help. All right, just have a thought, and we might need to set our damping to go immediately to a certain value, right? And that's a common in damping, proportion damp, and a few other of the components as well, and here in the swiper. Okay, is the immediate call. Now when we refresh, we get back to our smooth, our motion there. I would totally call it smooth motion because there's no damping on it, but we get back to our proper motion. Alrighty, next, we're moving along. Here's our slider. We've made a new custom button for the slider, and we're passing in pizzazz. So this is that pizzazz I mentioned way back at the beginning as we were looking at this, and we're making a shape of a magnet. I almost went with oval. That looks like this. Oval and oval. Almost. Did I save that? Refresh here. Okay, not bad. Maybe make that a touch bigger. Not that way. Just here. Like if we made it at 100 and 100. And you can change colors if you wanted to. We could make that green and pink. Oh, yes, that looks lovely, doesn't it? Refresh. And there's a bigger pink dial. If you want, you could change it to a cloud. Right here, Pizzazz list shapes will list our shapes, cloud. And this is Pizzazz 1, by the way, which does backings, which can be used for backings for buttons and backings for panes, things like that, or just as shapes themselves. There's a bunch of them. And it just kind of gets across the idea that when we set a backing like this, we're making a shape. You can make any shape you want. Okay, using ZIM shape, or you could pass in a bitmap, like a frame.load assets, and then frame.asset, and pass that in here, and you can get a picture for your slider or a button. We refresh this, and there's a little cloud going. Cute, huh? All right, we've been long at it. Let's carry along here. There's the damping that we had mentioned before, where we are damping, and we also, depending on where we put our slider, we might want to make the damp go immediately there. Otherwise, we might see a motion of something anyway. So there we are, damping to the slider's current value. Or sorry, we're damping, and then we're saying this first parameter is, hey, start off our damping formula at the slider's current position. It's like immediate, but it does it right as we're creating the damp. So we can do that in one move rather than saying give me a new damp like that, and saying slider damp dot immediate, and then putting that in the immediate call. Oh, the underlay. Okay, here's the underlay. We've got it the frame color. Let's make it blue, and we can have a look at the underlay. It's the last thing that we look at here. So there's the underlay, and as we change the scale, take a look at what happens. Now it's kind of interesting. I'm not sure. Maybe it's because yeah, I think that's what it is. We didn't damp. I should have proportion damped the underlay. Yeah, because I think as we damp it, well, maybe it doesn't matter when oh, even there, I sort of noticed that. It's funny. There it's perfect pretty well. At the top, it's close to perfect. It's only a small gap. But watch in the middle, it's kind of bigger gap, and I'm not exactly sure why. It still covers it, and that's why we made that dot. You can see the dot there. It made it. I want to see the dot a little bit better. I think we need to go something like, what do we call it? Display dot. We can't just go display dot alpha equals 0.5. That doesn't work. It's a DOM element, and we need to go dot DOM element like that, dot alpha. So this alpha can be placed on the DOM element, and so we say display dot DOM element dot alpha. So I just mentioned that. It is commented. I talked to you about that in the ZIM bits example there, where we were rotating the cube. So we refresh here, and now our DOM element. So that's basically the whole canvas for ThreeJS. It still works, is there. So that's our circle in the back. And I mean, that's acceptable. Probably be okay. Now, we do something similar to that if we wanted to lay out something that we were interfacing with on the phone itself. But what we didn't do is, as we rotate this, note that we did not rotate the underlay. I just didn't need to. By the time we get to there, you can still click on it, but at some point you can't click on it anymore. So it wasn't really moving. So I didn't even bother with the rotation. You can do the rotation. What you need to make sure is your element here has around the axis that you're going to be rotating. So your registration point is in the middle, which I believe it is. Because I think we center reg that when we put that on the stage. Let's just take a peek. Underlay dot center reg. There it is. So what you would do is change the scale X. So you would use a ZIM proportion on there, or do the calculations yourself to change the scale X. So as we rotate, based on the rotation at this point, the scale X would be 0. And what would happen is this would be really skinny like that. And when I'm a quarter of the way, like that, the scale X would be whatever, a half or a quarter or whatever is needed. And then these edges would pinch into there. And everything else would pinch in. So if I had little boxes on here, the boxes would be smaller. Now what we're not getting, I guess, is the sort of perspective of it. There is a skew, and depending on how the situation is, I suppose you possibly could skew. What we really need for this, though, is along with the skew, we need a basic transformation that is a perspective transformation. And I'm kind of looking forward to getting that at some point, and that would be through Create.js, and they probably maybe they need it through something else as well. Now, I'm not sure. There might be ways to, I think there were tricks to be able to like skew and get perspective by nesting things and skewing both of them, or skewing two nested things or something like that. So there probably is a way to really actually get skews on here so that your rectangles would map directly. In this case, we didn't need to do it, but I have done things like that before, and it's relatively effective. Well, it's perfect once it's working. It's just it's a little bit of a pain to implement, and that's because once again we possibly could even if we were to put objects in ThreeJS, it's sometimes a little bit tricky to click on them. I mean, it can be done. We'd have to make each icon a different 3 object rather than like a material, or you could possibly overlay different ThreeJS objects on the material, which is showing you, icons. Even then, if I were in ThreeJS, I would probably end up just using a ZIM hit test grid or something like that, or the equivalent of it, and actually code that rather than maybe make certain things interactive. But anyway, you're welcome to kind of look into that. That's some of the advanced things for interactivity in 3D. In this case, you see what we've done, and that's certainly good enough to get by in presenting this, I believe. All right, we've certainly made a mess of this, haven't we? Our colors are still sitting over here, all broken. We've got stuff showing, cloud for scrolling. I think it is time to end this capture, don't you think? Just how about a touch of a review? Did we get to the very end there? Well, I don't think I showed you the dot. It's pretty straightforward. If the dot cursor is not a pointer, then don't bother doing anything. That's sort of what we put in there. And the set dot was taking a look to find out if the value of the dial was less than 1/5 of the maximum that it can go to, so 1/5 rotation, or the value of the dial is greater than 4/5 of it, so closer to, so in both those cases, we can see the circle. And if that's the case, we set the pointer or the cursor to pointer, otherwise we remove it. And then when we click, we're just checking that pointer. We could have done it with a check variable or various other ways. Or we could have, as mentioned, we could have removed the event completely and added the event otherwise. Just beware, this is happening all the time, and I thought that was a heck of a lot of adding and removing events, and maybe it would be best just to use the cursor property since we were doing that anyway. All right, and we hit the end. Woohoo! Okay, cool. So we saw how to make that thing. We created a helper object, a 3 helper object that we've imported with ThreeJS. And so, oh, sorry, with from ZimJS right up here. There it is. And there, by the way, is us bringing in the phone assets, the JS, so that we could hack that. So we then hacked that data by doing this kind of thing. We took it and went into the materials and changed the materials. This was converting it to that number as mentioned. We saw the swiper earlier when we looked at the simple example. Just keep the simple example in mind as well. You know, hey, it was no problem at all just taking a 3D object and controlling it in there. That took us 5-10 minutes. All right, that's wicked. I am Inventor Dan Zen. We're here at ZIM Capture, zimjs.com on 3D. We've got 1 capture left in this series as far as I know, and that capture will be on, what we're doing, extending ZIM. Ooh, so some object-oriented stuff of extending ZIM. Ciao from zimjs.com. Have a great day. Thanks for sticking around.